All right, this weekend you are working on, well, I shouldn't say this weekend because next year it could be different. But in this video we're talking about vectors, and we'd like to introduce what a vector is to you, just so you have kind of an idea. Vectors are used, they're the mathematical representation of all kinds of things. You can represent the wind with a vector. You can represent the force of a hockey puck with a vector. You can represent the force of a moving vehicle or the weight of an object, or all kinds of different things can be, in the physical realm, can be represented with vectors. But a vector basically is just a mathematical representation of something moving in a particular direction with a speed or a magnitude or a force. Now, hopefully all of you have seen Despicable Me. 1, because Despicable Me 2 isn't really as good, and one of the reasons is because of the villain in Despicable Me, the first one. And his name was Victor. Now, he changed his name to Vector because he was, as he said, he was committing crimes with both magnitude and direction. The two quantities that a vector have are magnitude and direction. Now, magnitude refers to the length of the vector. So length of the vector is magnitude. It's all about the length of the vector. And as we'll find out later, we'll use the Pythagorean theorem to figure that out. And the direction of the vector has everything to do with the angle measurement. So if this line right here represents 0, and this one represents 90 degrees, and 180 degrees, and 270 degrees, then you can see that this is a, maybe it's a 40-degree angle. Okay? It's not quite 45. It's not halfway between 0 and 90. So I would be estimating, okay? But direction refers to the angle measurement. So we have a magnitude, which is the length, and a direction, which is this angle that you see measured from this part of the x-axis. And yes, we do measure the direction from this part of the x-axis, even if the angle, or even if the vector was drawn down here, it would still have that angle going all the way around. So you are going to be asked to draw a vector. That is not difficult. So you'll be given a graph, and you'll need to locate 1, 2, 3, 4, 5, 6, 7, and 4, 7 will be here. Excuse me. And here is that vector. You'll notice that I used this 4 right here and this 7 right here to find the end of the vector. You'll also notice that when we write vectors, this is the notation we use. We use these little inequality symbols, I guess, is what they would be called. We don't think of them in terms of less than and greater than, though. We just use them kind of like parentheses. But when you see those, you know you're talking about a vector. Instead of just a coordinate, you're talking about that hypotenuse, if you would say, if you wanted to call it that, because that's pretty much what it is. We could have another one, right? 1, 2, 3. 1, 2. That's the end of the vector. And so there we have that vector. It has a length, but obviously the magnitude of that vector is smaller than the magnitude of that vector. Okay? And then we can also eventually, we'll find that angle right there, which is the direction of that vector. You're going to also be asked to sketch a vector given 2 coordinates. So you notice in the last 2 examples I drew it starting at the origin. That's not necessarily true all the time. You may be given 2 coordinates like this. So example 1, 2, 3, 4, 1, 2, 3 is the initial point. They call that one the initial point. And then the other one, negative 3, 5, 1, 2, 3, 1, 2, 3, 4, 5. This one is called the terminal point. But here's the vector. It also has a magnitude, which would be the length of the vector, and a direction. Okay, now a lot of times we will pick that vector up and we will attach the initial point to the origin. So you'd have something like this. In fact, these would be called equal vectors. As you can see, you move 4 to the left, 7 to the left, and 2 up. So I go 3, 4, 5, 6, 7, and 2 up. This would be an equal vector to the first one. And then we can talk about its magnitude and its direction. But that force doesn't necessarily have to start at the origin, but a lot of times it's easier for us to understand it if we drag it over and put it there. Now, how do I find magnitude and direction? Okay, so we know what the vector 1, 2, 3, 4, 1, 2, 3, 4, 5. So here's the vector. Just a very simple vector. Okay, now realize that it's a right triangle. It's got a side length of 4 and a side length of 5. We're trying to find the angle measurement inside there. So we talk about finding the hypotenuse. You know, in fact, so the magnitude would be like the hypotenuse, and we know how to find the magnitude, right? A squared plus B squared equals C squared. Well, we know in order to get C by itself, you would take the square root. You know, if we call that C. So we have 6 square root of 16 plus 25. 16 plus 25. So the magnitude of this is equal to the square root of 41. Now direction. Direction would be that angle measurement. Well, good old SOHCAHTOA, right? Opposite over adjacent. That's a tangent issue, so the tangent of the angle is opposite over adjacent, 5 over 4. We know from our earlier studies that tangent inverse is the only way we're going to find that value. And with the handy-dandy machine, tangent inverse, 5 over 4, we find out that we get a 51.3 degree angle. So x is approximately 51.3 degrees. So that would be the direction. Magnitude and direction. You will have to be able to do both of them given a particular vector. I've already kind of talked about equal vectors, so just keep in mind, you know, a vector that looks like this could be moved over and attached to the origin, and it will look parallel and it will run in the same direction. It will have the same angle, but that vector and that vector are equal vectors. Now, polar form. How can you write the vector in a polar form? Now, you're probably asking yourself, polar form, what's that? You are very used to quoting things in terms of x's and y's. That's called the Cartesian coordinate system, where you move left and right and up and down. And you may have to end up seeing this in class for it really to make sense, but a polar coordinate, so sometimes we call it a polar coordinate, has a radius and an angle. Well, that kind of sounds like magnitude and direction to me, and that's exactly what it is. So when we talk about the radius and the angle, we're really talking about the magnitude and direction of the coordinate. So we know that the point 4, 5 is, you know, somewhere up here. Instead of moving along the right triangle following the legs of the triangle, we polar form to get to this coordinate means we would rotate a certain direction till a stopping point, and then we would follow the radius to get to that point. So the Cartesian coordinate system, x's and y's, would have me follow the legs to get to that coordinate. But the polar coordinates would have me rotate and then follow the hypotenuse to get to that particular location. So it's somewhat similar, but a different looking system. Now, we already know the radius and the angle because we just did this example. We found that the radius was the square root of 41 and that the angle was 51.3 degrees. So you do know how to find what we call the polar coordinate. It's just the radius and the angle, which we know them as magnitude and direction. Now, if I give you, given the polar form, sketch the picture, so I give you a radius of 2 and an angle of 30 degrees, then what you're going to be doing is rotating up 30 degrees and then taking 2 steps out. So this is 2 steps out this way, and this is about a 30-degree angle. So that is a polar form sketch, or given the polar form, sketch the picture. So we're talking about a vector heading in that direction, right? If I wanted to find the side lengths of the triangle, that would be the x and y, or the normal coordinates in the rectangular system. I could do that. But we know how to do that because we've studied the 30, 60, 90 right triangle, and we also have our sine, cosine, and tangent that we could use. In this case, we would use sine, obviously, for the y, and cosine to find the x. Okay, but we don't need to do that. If you're just given the polar form and that you're asked to sketch that, that would be the vector that you would sketch. Okay, see you in class.